Well, hello everyone. This video is part 3 of the Hazelcast Cache tutorial series. In this video, we'll specifically look at Hazelcast Jet, which is a distributed stream processing engine which runs on top of the Hazelcast architecture. In our example, we'll specifically use it to keep the cache that we got from database refreshed as the data changes on the database. And this correspondingly ties in very closely with the work that we did in part 1 and part 2. So for the agenda, first the viewers need to look at the prerequisites before they can benefit from this tutorial. Then we'll look at the Hazelcast Jet, very brief overview of what it is and what it does. An architecture diagram that illustrates what we are trying to achieve in this tutorial, the corresponding data model that we are going to use to support our application and provide the data for streaming and caching. The architecture patterns and use cases we'll discuss before we're discussing the code to see under which scenarios and circumstances these patterns can be used to benefit the organization or whatever enterprise you're working for. And in the end, we'll look at the demo of how this application is working and its architecture is supporting our respective direction. So let's look at the prerequisite. So first, the user should by now be familiar with Java JDK, which is how to run, compile, and run the program. Eclipse, the integrated development environment that we'll use to write our program. Maven, which is the build tool integrated with Eclipse. The MySQL database we'll use for providing the data to our cache, to our program. And then in general familiarity with database logs and change data capture, all the database basically maintains this log information that captures the state of different database, different tables, records as they change over time. And that's what this stream processing engine is going to do to read the changes from. Then some familiarity and understanding of with events, messaging, topics, and subscriptions, which are cornerstone for loosely coupled architectures, like a topic subscriber model where you can send notifications and the other clients or can read from that topic instead of making a direct synchronous call, having a strong runtime dependency between the two components. This pattern is very widely used in the microservices architecture across the systems and even within the components within a major system itself. And then I'll also provide links to some of the description. So let's look at the Hazelcast Jet. So Hazelcast, as I mentioned before, is a Spring Boot Java-based cache, distributed cache management. And Hazelcast is a distributed stream processing running and utilizing the same framework, same architecture as Hazelcast. And in this case, because it provides a stream processing capability, we are able to stream the changes from the database or use it in the capacity known as CDC or change data capture. As the data changes on the database, we're able to read it and populate the cache on the server with that information. So going over to the architecture, this is what our architecture looks like. In our case, in part 1 and 2, we basically worked on this Hazelcast cluster setup. In this case, we'll actually run separate Hazelcast standalone Hazelcast Jet nodes other than the program and submit jobs to that node. And these jobs will basically monitor the data changes and load that information into the server. These servers can, again, just like Hazelcast, by using multicast, can be form of a cluster, which means that if one of the server goes down, and you have submitted a job over there, the other server is able to pick up the job and start getting streams or start processing the streams or changes of data that happens on the database and start and can do the processing, and in this case just keep refreshing the cache with that changes. So the limitation on this architecture was that it loads it once and it only reads it once from the database, and until that value is evicted from the cache, it doesn't get any notification that the cache has changed or the data has changed and cache needs to be refreshed, unless you keep monitoring or manually keep refreshing that cache. In this case, this is with the stream processing, we're able to refresh the cache with that data and write our own processing of how we want to load that information into the cache. Especially for reference data, you can load everything into the cache, and if it changes, then you are able to, if new values are added or the existing value is changed, then you're able to just read that information and populate the cache in it. This program that you see over here will be used, this is a test program, and we'll use it to ascertain the fact that the data changes have been loaded into the cache, and we'll connect to the Hazelcast Jet Cluster to get the latest information about the cache. So that's the architecture. We'll not likely won't do this part of it, which is loading it into the remote Hazelcast Jet Cluster. We'll just load it into the local cluster, and then hopefully in part 4 should be able to load it into the remote cluster. And again, in this case, this is the multicast IP address and port, and these are the two servers running the services, Hazelcast Jet services on 5950 port and 5950, both of them the same port. The two servers are different, 192.168.1.1.1 and 150. Okay, just a quick overview. So microservices, if you're familiar with it, is the pattern used to componentize and break up your application into smaller chunks, and these are independent deployable units, and they are connected via as I mentioned, technologies like like events, messaging, topics, and subscription. So event is something that happens, topic is what you're subscribing to, that's your subscription, and you get a message when that event basically happened. So, and then there's a queuing concept that you can queue up the message, and so you don't lose any changes that you have not absorbed or have not listened to. So those are some of the technologies which are used for microservices architecture that makes them independently deployable, scalable, and manageable. Primarily is done for enterprises that are too big and it's become difficult for them and their monolith applications to manage different changes coming in from different directions. So when you componentize your application in this way, you're able to not only deploy them independently, but you're also able to deploy them while the applications are running with minimal disruptions on other services, because they are communicating with one another, likely through asynchronous, like topic and subscription based model. So the sender doesn't have to know that the receiver is there, and receiver can come online later and absorb that event later in time if it hasn't received or it was offline for some time. So your server behaves in a graceful degradation mode until all the components are brought up, and instead of having a bulk deployment where you take down a big part of your system and it is offline for a few hours and very disruptive for the day-to-day business or for that organization. So that kind of, with that, we look at the architecture pattern for this case. So we just talked about microservices, so events and messaging for. So what this architecture does with Hazelcast Jet and database directly reading the change data capture and publishing the events is that it allows systems that are older and they don't have this messaging based technology built into them, you can read and create kind of a pseudo messaging and eventing based system by reading from the database directly, capturing the logs and generating those events. So instead of, monitoring every record one by one, you monitor the logs. If any record changes, you're able to generate the event from that log and fan out, publish that event to a topic, and other clients can subscribe to the topic and absorb that changes. You can also use that same eventing either between server one Hazelcast cluster, which is running that job and monitoring, just like in our case, and publish to other Hazelcast servers, but you can also publish them to the Kafka clusters. So what are the negatives? So not all database may have these compatible data capture technologies, because it's not just Hazelcast. We are using a underlying monitoring technology called Debezium that we will look into our code. So with Hazelcast, the Debezium libraries, we are able to monitor the changes, and the sample database that we are using is MySQL DB. So we're able to monitor the changes over there and publish that changes as it happens on the database, and those are for some of the older system which do not have the messaging. So we are directly reading from the database and from the logs and trying to understand as the data changes and publishing it out to different clients. Another con is that the table level data may not necessarily be in the right format, at enterprise level, at hierarchy, right? Because you're not really publishing a consumable event tailor-made for your different clients. Well, not necessarily tailor-made, more like generic for your different clients, and they can consume that hierarchical or canonical form and create different aspects of it. It's essentially a row that you're publishing, so it's not in the right format. So that's why it's a kind of a pseudo messaging system where you are exposing the internal, or maybe you can filter out some columns, but you're sort of exposing the direct table structure in this case to external clients, and instead of wrapping that information into more understandable and an enterprise-wide format that other clients can understand. So they have to understand your table structure, and if it is like one line, one format, if it is a special kind of characters being used or whatnot, if it's not in a standard way, then you sort of end up using or exposing that information. So it may not be best design practice, but architecturally it gets you there, especially for older systems, which have monoliths deployed and are writing directly to the database and do not have the eventing capability to notify their clients of the changes in the data. Okay, so next we will look at the code for this application and see a demo how this is working. All right, so we looked at the Hazelcast master, that was the REST application. This one is the change data capture CDC application, and over here I was kind of playing around, but the Jet job is one main class, and that's it. Right now, just for illustration purposes, one main class that I have put in all that information. By the way, just for information's sake, before I go to the code, I'll put this link into the description. I'm following this example for MySQL. However, this requires you to install Docker and create MySQL database instance within the Docker. You don't have to if you already have the MySQL version. You can just get the scripts that follow the table and the data and load it directly, the CSV file and the scripts, and you can create the table and load that information directly into the table and run it. And then it goes into the how to create a Hazelcast Jet. So you may want to download and get this Hazelcast Jet standalone node. So we'll execute it in two formats. One is the standalone node that's like the actual Hazelcast Jet server, and then the other one is the running within the Java program itself. So you can follow this example, or I'll just provide the code base and you can just download the example, create those tables, and off you go with it, right? So let's look at our program, and then we'll do a quick demo, and we'll operate that Hazelcast change data capture in different modes as a standalone within Eclipse, and also as servers forming a part of a cluster, and continuously monitoring the database. So what we have here is and by the way, behind the scene, it is using some Debezium libraries. Let's see if I can find, yeah, these libraries. These libraries are being used, which is a change data capture and interface tool for my MySQL and other databases as well. And Hazelcast is dependent on them to load the data and generate the stream. So what we are doing over here is create a stream. So these are all Hazelcast provided object stream source jet pipeline, stream source stage. So stream source stage is composed of the change record. The change record there again, change data capture kind of record, and creating a source, and you can call it whatever you want. Why did it go down? Okay, you can call it whatever you want. Now this is the URL for the database, which is the address, the port, the user and password, whatever you set for your local database, and the cluster name, which is for this is standalone. So when we are going to connect to this cluster to read the cache from, we're going to need that cluster name. Then you have the Hazelcast whitelist for the schemas that it is going to monitor, and the whitelist for the tables that it's going to monitor. So in our case, this is running on the local 192.168.1.1.1, and the schema is this one, cache Hazelcast others, and these are the two tables we will monitor. And you can, since it's a comma separated list, you can monitor as many tables as you want to. Okay, so create a pipeline from we create a pipeline, and from the pipeline we direct the pipeline to read from this source which we created earlier. So now the pipeline is ready. Now we need to dump this pipeline. So the first thing is to write to, so in this case, it's it's writing to a local customer cache. So it syncs to a call map. So in this cache / map, we have customer, we call it customer cache. And the two values that we are putting in is the ID, and then the other one is the customer whole class itself. So that's the first thing we are doing. We're getting a local customer cache and reading from the filtering only on the customer, because it is also going to read the customer dependent records, but here we just want to maintain the customer information in this cache. So that is one write or one sync that we are writing the data to. The other things, actually I have commented out a few over here. The other sync that we are connected to, writing to, is somewhat more complicated. So let's look at what is the difference, why they are somewhat more complicated. Is, if you recall, this is how we stored the data, and we had customer information that is by ID and a whole customer object. So it's key value pair. Here it's not so simple. It's key value, but the value itself is a hash map. So it's a hash map of hash maps. So and that's what we are doing in the second part of, or in the second sync. We are creating a customer dependent cache, but that cache is not referenced by the customer dependent ID. It's referenced by the customer ID. But then this customer can have multiple dependent. So what this is storing, it can store the list of dependents, but it can also store a list of dependents themselves represented by their own IDs. So it is a customer dependent customer ID, and then you have customer dependent ID and the customer dependent object, dependent ID, dependent object, dependent ID, dependent object. So each hash map is composed of the customer dependent ID and customer dependent object, and your main hash map, your main class, your main cache is composed of the customer IDs, where the values are represented by another hash map which represents key value pair for dependent ID and the dependent object. So if we go back, so here in the customer side, we were just writing it to custom CDC to sync to a map, call it customer map. With this customer ID, we get from this change record, get the ID class, and from this value, and from this change record, convert it to a customer class, which is, let's just have a quick look at this. This is a customer class, which is ID, first name, last name, email. So these names have to, the setters have to match, or provide the JSON property over here, and they should match with the name of that column over here, and it's able to load that information into the cache. Okay, so once you have that, same thing with dependent, you're also able to load the dependent information, but we are using things to map with merging. So we are not just mapping it to a simple map, we are merging it with it. What it means is that first the code will see, is there any existing value against this customer, because the same customer will get multiple dependent records. So if there is, it means an hash map already exists with one value or two values, so it will add another value to it. If none exist, then it will create the hash map and put the first dependent in it. So let's look at the code again. So this is the key. So key is the customer ID, which is this one, and then the value is if so this is basically creates the value, and this one, if it already has a value, then what do we do? So if it doesn't have a value, it will just put the customer hash map in there, a customer dependent hash map. So we create a customer dependent hash map with integer and dependent object. In this customer hash map, we put the customer dependent ID. Remember, this is the customer dependent ID for this. So let's look at the customer dependent object. So customer dependent object has its own ID, first name, last name, and customer ID. So if we go to customer dependent, so you have ID, first name, last name, and the customer ID, the parent's ID. Okay, so in the Jet job, it is getting the dependent ID, that is this ID. Okay, so that is also this ID, this one, not this one, this one. Okay, so we get this customer dependent object, we put in ID, which is the key, and then the value we put in is the customer dependent. So it's here, this is converting it to, hey, please convert it into a customer dependent object, so which is this one. So this value is being put into this hash map, and this hash map that's being returned, this one, is actually this hash map. So you get the value. So the value itself is a combination of key values, a hash map. The value itself is a hash map, customer dependent hash map, and that hash map has list of customer dependent objects, each represented by their own or keyed by their own ID. So key value within the hash map, and it itself, hash map, is a value to the bigger hash map. Okay, so we got it over here. Then what if we get the second record row? So this is, it took me some time to basically get this logic right. So if I go back to the database, come on, this one. Yeah, so if we go back to the database, you see, if I get this one, so that's fine. But if I get another one, 1002 for the same customer, it's another dependent, John Doe and Jane Doe, what should we do? Well, we need to add it to that. So this is what the merging does. So what it merging is saying, give me the old value and the new value. So you get the old hash map. Again, the value is not the customer dependent object, the value is this thing, the hash map, and the new hash map. Right, so I got the new hash map. What do we do now? I found there's already a customer ID with it. So what it does is basically, So what this does is basically gets the key set of the dependent hash map, and it gets the first value for the new. So new one, the new data that just came in will only have one object. And so suppose there were 2 or 3 objects already there, or 2 or 3 dependents already there. So another say record comes in, and in this case this record is say Jill Doe. So you already have John Doe, Jane Doe, and Jill Doe. So Jill is not there in that list. So what this code does is basically, and this has already been computed, so this is ready to be saved to the cache, this whole hash map. But then this fires because it tells the customer dependent cache, hey, you already have 2 items or another hash map with 2 items in there. What do you want to do? How do you want to merge it? And that's exactly what customer map with merging does. It takes this next this old value and the new value and lets you decide what you want to do. So what we are doing over here, we're taking this new value, this one that we just created. It's always going to create this value. Whether it's going to put it into the cache or not is up to us how we want to do it. In our case, we found an old value against that customer ID, this one, an existing hash map with say 2 value, John and Jane Doe. Now we are going to put Jill also in there. So what this does is basically gets the keys and get the first element from that key. Okay, and that first element from that key from the new value, which is the one that we just provided, that key is going to be this value, all right, which is the integer, which is our key, which is the only value that we put it into the new hash map. We have not set this new hash map into the memory. We just created this new hash map. We created the first one, we put it into map, and we create the second one or the third one. This logic will fire. It will create the second and the third hash maps for each of those Jane Doe and Jill Doe, but it will not put them in the map memory. It will let you decide, because it already finds an existing hash map belonging to John Doe for the first case. Then we will add Jane Doe to John Doe. So how are we doing it? We get the new value that we just got, and which we have put it into hash map. So we get the key set and we get the first element from that key set. All right, then that first integer, obviously it's only one member in there. It's only this one customer dependent object, and we get its ID, and we use that ID of that customer dependent hash map that we got and put it into the old hash map. So we had an old hash map that had these IDs in it, 101 and 102 and 103. Now we put 101 and 102, and now we put 103 in there. So maybe we can just do a debug on it and see how it's basically working. And that's about it. That's how we are able to maintain parent-child relationship between customer and its dependents, by putting map of maps. You can also put these in the array list, but it's with this way you are also able to reference a specific item within the map of maps. Okay, and the other part of the code we have commented out. So let's just run it in a debug mode. That will help understand what's really going on over here. Okay, let's put a debug map over here, and let's put a debug point over here. So before I run this program, I wanted to share that Hazelcast, when you're running in Eclipse itself, gets its configuration from this hazelcast.yaml, or if you create another configuration file or XML, there are 2-3 different ways for doing it. But even though the multicast is enabled, it's not going to participate in multicast. This is a standalone within Eclipse version. The other way we'll run it is directly deploy our job to we'll build it and deploy it to a Hazelcast server, which is a separate runtime environment, and those servers have their own configuration in their config file, similar to this one, and they will then form a part of a cluster if you're running more than one nodes with the similar configuration. In this case, the cluster name and multicast port and host and IP address and port information. If they match, those multiple servers nodes will become a part of a cluster, but this one will only run one jet job. So before we run it, let's see if I have our breakpoints. Yeah, so I have my breakpoints here, and this is just to show you how, and yeah, towards the end of it, we're just submitting the job, and I'll get to that code in this part that I've commented out, which is used for sending data to another Hazelcast cluster. We'll look at it in part 4. So let's run the program. Okay, and make sure you do not have another Hazelcast instance. So I don't have any other Hazelcast instance running or nothing here. Then I check my local computer that I have. I don't have any Hazelcast instance running over here. I'll also run the same program in this one, and you will see both of them will start listening to the same data. Okay, because they both are going against the same. So if I look at the jet job, they are both going against the same database and monitoring the same tables. They have the same code base, both of them, basically. Okay, so let's run this program and let's see what happens. Jet job, and it should debug, and we should be able to see what's going on in that. So we switch it. So now customer dependent hash map. So first, putting in a customer dependent hash map, and in the customer dependent hash map, we created the first item, which is customer dependent, and it is against customer ID 1002. So it is against this one, right? And this is this item, right? So if I come back, if I run it, okay, it did not really go in here. And the reason why I didn't go in here is because this is the first hash map that you added to 1002. Now this is the second customer for 1002. Its ID is 102. So what if I run it, if I press the continue button, it's gonna jump in here, meaning that Hazelcast is now doing the merge, and it is able to find an original customer dependent hash map from the cache. In this case, it's able to find this one of hash map, and it's up to me to add the new customer in the same hash map. Okay, so if I continue this, now it jumped over here. So what are the old and new value? You see, old value is a hash map which was put in together, right? And now in the hash map, I basically also, by the time I came here, I also added the new customer 102, right? New value, on the other hand, is just the hash map with 102. It does not have the it's just the new customer. So if I just add this new value and replace it, you will only get the last dependent item because the previous dependent will be replaced. So you have to extract out the new dependent item from the new hash map, right? And put that into the old hash map, right? And you have to do it for each customer against which there are dependent object. Let's go further. Now this time we got customer ID 1003. When we do 103, it's not going to jump in here because we don't have any customer with 1003, and this is the first dependent that we are adding, so we'll just add it there and it's not going to jump here, so it did not come here. That's good. Now it went back here. Now we get another customer, one in this case is 105 being added to 1003. Now it's going to go through this logic again, and now you see we added the 10010, so old value now it becomes two, has two customer depend, used to have only one, now it has two, 105 and 104. So both the customer dependents are now added to the same customer 1003. Okay, so this is the hash map that against which we are adding the two this is a customer object against the parent object, and so we are adding the two customer dependent, and this process is going to continue. So let me remove these breakpoints now. I think that the logic should be clear. So once we have okay, make sure that okay, so I don't know why it's doing it. Maybe I don't see the breakpoints. It keeps doing that. So let's see what we got basically. So all the dependents were added to the customer cache, right? And there's also this peak. This actually allows us to print this information onto the console. Okay, so we have all the customer dependent, but how do we know that we really have it? For that, we can actually go to this cache read from Hazelcast program, and this, what this does is basically connects to my local server at 5950. So remember, we have this one running on 5950 and the cluster jet test runtime. If you don't provide the connect cluster name or port or the network, then it's not going to connect. So you have to cluster name and then the host and port, and then we'll try to run this. And what this one is doing is basically going against the server and trying to get all the cache basic information. So in this case, we get the customer cache, then we get the dependent cache, and dependent with customer ID ASCII. So I tried to create two kind of dependents, out of which I only populated this one. This one was supposed to be just a dependent ID and dependent object, similar to this one, but then, you know, there's no use case for it. This is a better use case. That is, you use the parent's ID to have the child objects in this hash map configuration: parent customer ID, the dependent's own ID, and the dependent value, the whole object. So you will see. So let's run this. Okay, and we go to this, see what happens. Okay, just want to make sure okay, I'm not connecting to the right server. Let me just connect to the right server over here, I believe. Yeah, I was connecting to 150, which was the other machine. Let's run this again. Go back to terminated, so that's good. So if you see, it got the customer information. It did not get any dependent because we did not load anything into the dependent cache, but we loaded things into customer dependent with customer ID ASCII cache. So there are three kind of caches that we are monitoring: customer cache, customer dependent cache, where we did not load the dependent ID and dependent object, but this one where we loaded the customer ID and a hash map of customer dependent objects against each customer. So you got something like this, like if you see, this one is against customer ID 1002, 1002, and then 1002. So three customers against dependents against 1002, and again 1003 is one customer dependent, another customer dependent, and another customer dependent. So that hash map that with merging is doing the magic. It is taking a new object, and with our code, it is merging the new object into the dependent hash map of the existing old value that we already have there in the cache. All right, so far we were able to read the values from the database and publish in on our console. Now what we are going to do is change that value dynamically at runtime, and we see that Hazelcast has created a job that's constantly monitoring those tables, in this case customer and customer dependent, and as soon as we change those tables, you will see those entries. So I try to change and you'll see these two entries started up here. So let me go back to the table, excuse me. So let's run this, get the table information, and let's take it to Don. Let's just change it to Donnie, from Donnie to Don Wong. So it's gonna execute this update statement. It's gonna update the first name to this one, and we finish it. Correspondingly, you will see some messages appear over here. So it was Donnie. I was playing around with this as Donnie, and then it changed to Don. So it's able to monitor the changes in the database and able to publish those messages. In this case, we are capturing that information in the cache. So in order to make sure that we got this in the cache, I'm gonna run this program again, and this Java application, and go back to this application. But this just message is showing that a client connected to it, and over here you will see 108 is the one that we changed, and the name is Don Wall. So let me try that one more time and just completely change it to Don number 2. So now this is Don number 2, and then we will say apply, finish, go back to our main running job, and you will see these two have been printed, Don number 2, and it's probably printing it from two different places. One is I'm printing out, and maybe some other debugging going on that's printing out this information. Now we're gonna run our cache reading application. So it's gonna try to read the cache again. So let's see, this is our connection information that a client tried to connect to it, which is this one. And then you will see that it got Don number 2. So what really happened is that the data change in the database, the job was monitoring through Debezium the change data capture logs, and it is logged that information and generated an event corresponding to that. And using that event, hooking into that event, we were able to load that information. Into our maps. In the first case, we were just directly loading it into the map, and then in the other ways, we are sort of merging it with the map. All right. Now, one more thing before we wrap up the session. The same code I'm going to run on over here, the same jet job. I'll make sure the configuration is correct. But first thing you will see, it will not form a part of the cluster. Basically, it's going to connect to the same database, which is running on over here. So the database is basically running on the same server where the first program is running, which is 192.168.1.1.1. And this is my local machine that I have, which is outside of the remote desktop. So I'm doing a remote desktop connection. So what I'll try to do over here, so I'm gonna run Java application. And you will see that it will not talk to this guy. Even though you have the multicast enabled, it will not talk to it, will not form a cluster. It will, so if I go over here, it is its own cluster. Just me a second, let me find out the cluster information. Okay, I don't find it. Somewhere hidden in the logs. Okay, and let's look at maybe this one have its own cluster information. So distributed acyclic graph. All right, so these two servers are now running, and cluster name is jet test runtime, and starting at this one. So yeah, so okay, so it started at 5950, and this one is on 190. So this one is 11115.950, and this one is 155.950. So you have two servers running, but they are not part of the cluster basically. All right, so but they will both monitor the same database. So if now the database changes, then you will see both of them will. So this time I'll pick a different record to change to, so that it's clear that it's picking up the information. So let me just change to Christy Wong. So it becomes Chris to Christy. So we apply. I'm gonna change set names. A quick way to basically change, instead of writing update script, just directly change it there, and you can see there's two messages that came in. It became Christy Wong, and over here you see it also changed to Christy. All right, so it read all the information, and then I changed the information, so it's read the new information, and as a pipeline I able to. So now the cache is residing on both servers. So if you want to check the cache on that second server, we go back, and we already checked the 111, so we are going to check 150 now. So I'm going to check 150 now. So it's gonna send a message that it's trying to connect to this guy over here. Meanwhile, here we go to the terminated one, because its program terminates, and it's able to load the same information cache. But there are two servers running, but they are not sharing the information. They're not from part of the cluster. All right, but they're looking into the same database. Okay, the reason why they're not, because we are running it in Eclipse. So now what we're going to do, I'm going to stop both the servers over here, and we are going to stop this server as well. Now both the servers are stopped. Now we are going to run a standalone Jet instance. So for a standalone Jet instance, you have to have your command prompt, and you have to know the commands that you are going to execute basically. Okay, so this is my remote desktop. So now on this machine 192.168.1.1.1, I'm going to start the Jet standalone outside of Eclipse, and that's for monitoring. And the command to start it is jet-start. All right, and then we'll execute a second command, which is basically deploy our application to this node that's going to run. So in order to compile your node, what you have to do is basically go to Eclipse, and then you say run as and Maven install, or you can use some Maven commands from the command line, and that should create a depending on your Maven goal that you have set up in pom.xml. And in my case, I'm just creating a basic without any dependency job, because the rest of them I'm expecting files to be available within that Hazelcast node. And here it's going to create a deployable jar file, and it also is going to have a manifest file that will say please execute .jet job, which is this one. Okay, so it's going to do that. If that file is not there, then you have to manually specify which file. So for that, just on a quick note, the the one on the CDC, the thing that I'm going to provide, this is the one that we are following. And you can basically run the Jet instances. Have they provided a Jet instance? Yeah, here it is. Jet, and this is like Jet stop and Jet instances. And where is my Jet? Yeah, here's the Jet start, and that will start, and then you will deploy the job to your cluster, so that Jet submit, it will submit the job. Okay, so in our case, I'm going back to our, so where is this? So this one basically creates a jar file. So it just created this jar file. So I'm gonna take this jar. So this is the one that we're gonna submit. But there's one problem with it, with Hazelcast Jet. You have to also deploy this jar file at the library folder within Hazelcast. So if you take this jar file, so you have to manually either copy it to the library folder, and otherwise it does not execute. So in our case, if I go to Hazelcast, this is the one that I'm using, and this is the lib folder, and this is the deployed, right? So let me just go back, copy this, and I'm gonna just paste it here. Okay, so it copied the file to the destination, and otherwise it gives class not found exceptions. So now I'm going to start Jet in a standalone mode, and I also need to copy the same file to my other machine. Okay, so let me also, since I have it copied, I will also copy this to my other machine. Yeah, so over here, this is my other machine on my local, basically, and I'm going to paste it here. So now both the Hazelcast nodes have that file in the root at the library. So now I'm going to submit the job to this. First, I'm going to start the server. So let's start the server. So this will start the server. So you will see that there's a server which is being started. Good. Okay. So now the server is getting started. Now I'm going to submit the job. In order to submit the job, you have to get this command line parameter, and where did it go? Here it is. So now I'm submitting the job, basically. All right. So now the job is submitted, and it is now reading from the. So if I change the table again, any value in the table, you should see messages start popping up over here. Okay. Now, since this job is submitted over here, if I just start the other instance on my local machine, it's going to participate in cluster with this. So let me also start. So the other machine that I have, this is outside the remote desktop. This is on my local environment. So I'm going to start the Jet start over here. So I started the Jet, and you should see that it forms a cluster with this Jet instance. Why? Because they are both using the same configuration. So where is the configuration? So let's just quickly, so you see some messages start and they are communicating. So so they both form, remember you have to keep the multicast host, the multicast port, and as well as the Jet instance, cluster instance the same. So if I go over here and if I click on this one, so this is the Jet Hazelcast YAML. So yeah, so I'm using 4.5.4, which is this one over here. Jet with adjustments 4.5.4, and you have the cluster name Jet Test Runtime 224.2.2.7 54328. Similarly, on my local machine, this is on my local machine, I also am using the same Eclipse version and Jet Test Runtime. And your own port could be different. It doesn't matter. This is the port which your individual servers are going to use. This is these ports that your individual servers are going to use to become part of a cluster, but it could be different, or the two doesn't have to be the same. Okay, so coming back to these two, so you can see these two files match. Jet Test Runtime, then you have the port, doesn't have to match, but the multicast for these two at IP address and multicast port. So now both the servers are part of the this cluster. So now we are going to try to communicate. So they are both still using 5950. So I don't have to make changes in my Eclipse program to communicate with them. So first I'm going to communicate with 111 and save it. So it was able to find two servers and get this information. Now the other one didn't, since it's a part of cluster, should also get the same information. So let's try the other server, because even though I did not deploy the job on the other server, and it's also able to get this information. Okay, one thing I will do is I will try to change the value and see what happens across the two servers. So first, let's look at the server over here. Okay, and bring your database into view over here. So we have the database ready, we have the server ready. All right, and then we also bring our server on my local machine. So this is my local machine. That's why, see, the window can go outside of this remote desktop window. Okay, so this is my local machine. So now I'm going to change Christopher. Okay, with Christopher, and I will try to fly. So it's going to change to Christopher, right? Fly. Okay, finish. So let's see what happens in both of my servers. So both of my servers basically should get the information that is going to change. So over here, maybe my eyes are not reading that quickly, but it should be getting the Christopher information. Here you have it on the other server, basically. So I'm able to read that information, and it got Christopher. So what we'll do, we'll just connect to this instance on both of them and see if we have the Christopher in the cache or not. So let's look at our client. So first we connect to 150, which is, remember, client is running on this machine, which is remote, and this is my local. So we'll connect to this 150 machine and see what value we get. So we connected to this machine, and over here you see first name is Christopher, last name is Wong, right? So this is this one we were able to change, Christopher Wong. Okay, then we go back and check against 111. Okay, and let's see. Now this one also first name Christopher, last name Wong. Both the servers has the changes in it. Now what happens? So keep in mind that this is the last. So this is the last use case. So what happens if I stop this server? So this one is the one that I basically launched, first on the remote machine, and I also submitted the job to this server, right? So this is my job information jet start, and where is my job information? Yeah, this is where I submitted my job information basically. Okay, so I have my job information here. So what I'm gonna do, I'm just gonna kill this session. So now this server is gone. Okay, so I submitted the so if I go back to my architecture, I submitted the job to here. Okay, this is where I submitted the job to. This is where I submitted the, come on. Okay, so this is where I submitted the job to. Okay, however, the idea is to see, can this server also get the job and start, in the absence of this server, can it start reading from this database? All right. So let's try that. Okay, let's see what happened over here first. So I was able to, did I kill the server or did I not kill the server? Okay. Let me just make sure that I kill the server. Terminate job. Yeah, okay, I terminated the job. Okay. Now, is it able to, the other server, is it able to read the information if it changes? Is the pipeline still intact? So I'm gonna change it back to Susan. Let's try this. Susan, and we'll apply. Okay, so we saw some messages here. Okay, so as you can see, it got Susan over here, which is 106, which is the one that we changed over here. So if we run our program and connect to 50, because we killed this instance where we originally submitted the job, see what values we get over here. So if you look at over here, and 106, yeah, this one. See, we got Susan over here. So we are able to get the latest information in the pipeline, even though I killed the original server instance where I submitted the job, but the job is still running on the other server instance. Now, what happens if I bring up this server instance, the one that I killed again, basically? So let's try to bring it up again and then kill the other server where it's running. And it would be amazing to see if this server is able to, now we don't need to submit the job again. I'm gonna start this server again on 1111. Okay. And let's see. So now it's part of the cluster. Okay, cool. Okay, now let's connect to 1111 and see what do we get. Do we get that Susan in here? We should be able to get that. Okay, so if we try that with Susan, so we are able to get Susan information. So now I'm gonna go back to my instance. So this is the instance, this is the command line. This is the instance that's running on my local machine, this one. So I'm gonna just kill it. So now the instance which is on my local machine 150, I'm gonna kill this one, 150. And now this one is gonna complain that sockets connection issue or whatnot. Right, so it's unable to connect with the other server. it's unable to connect to 150 is unable to connect, and in the end only this one will be left. So if we connect to this one again, we should be able to still get this information. But 50, okay, it is still showing 2. Now it finally showed 1. Now it's able to get this information, right? It's running a bit slow. $50 should not get any information because we just killed the server. It's not able to connect to it. Okay, cool. It's not able to connect to it. Okay, it's not able to connect to it. So now we're going to go back to 111, but we will make some changes in the data. So let's look at the last record again, and we make changes into make it Donnie again. So just send to Donnie again. Finish. Let's see what happened with the server. Did the server get the information? So you can see it's able to get that same record again. So even though I killed, first I deployed the job here, I killed this one, the other server was able to pick up, it started replicating that information. Then I killed that, and it started this one, killed that instance. The job replication through the pipeline started happening on this server. So it's a pretty cool feature. As long as any of the node is available, the job is going to keep working. To double check, let's run it against this 111. And you should see that the last record over here is go back to Donnie, which is what we changed in the database. We changed it to Donnie. Yeah. So that will be the end of this session. We saw how we can run Hazelcast with an Eclipse. Then outside Eclipse are 2 separate nodes, make them in a cluster, deploy our jobs over there. Oh, one thing to remember, one more thing, is when you deploy a job to a cluster and you run this command, that submits the job to your cluster. This is where I am building my job. The Hazelcast basically uses client, just like you have hazelcast.yaml, you have a client YAML, and the host and port and cluster name should match, because that's where it's going to submit the job. So when you run it, it will get the client server information from the client YAML file, and then submit the job to the server identified in this file, right? And it will submit it to this server over here that's running on localhost 192.168.111. Basically, it's localhost, and 5950. Multicast doesn't matter in this case. All right, so that will be the end of this discussion. Thank you.